We will now find the potential energy if we have two charges, Q1 and Q2, at some distance r between them. So what is the potential energy of this system? So to do that, we'll take charge Q1, which we'll take as positive, and we will take the charge Q2, which is going to be very far away. So it's Q2 is here, also positive. And then we bring this close together and bring it to a point here, and this distance is some distance r, and we're going to bring it from here to here, and then we'll see what is the potential difference, or what's the potential energy of that system. So now, as we bring it closer, the electric field is pointing outwards, and this is a positive charge, so we have to do work to bring it in, and the work will be the increase in its potential energy, and that is, or can be written as Q delta V, because the delta V was defined as delta U over Q, potential energy per unit charge. So the work is going to be Q delta V, and the Q is Q2. So we can write it as Q2. Now the delta V between these two is V final minus initial. So V at, let's call that point A, let's call this point B, it's going to be V final minus initial. And so that's going to be Q2. And the voltage at B is going to be KQ1 over RB, because the potential here is due to this charge, minus KQ1 over RA. And since RA is large, or actually we tend toward infinity, therefore VA is 0. So this term goes to 0, and the work done, or the delta UE, becomes just this term. So it becomes K Q1 Q2 over RB. This is the potential energy of two charges which are at a distance RB from each other. And it comes about because we have to apply a work or force to bring it closer. The work done becomes the potential energy of the system of two charged particles. Now let's suppose we have the same thing as we have here. We have Q1, and let's suppose we have another charge here, or let's suppose we bring the Q2 over here. Okay, this Q2 has now reached that point, and we bring another positive charge Q3, and we bring this charge from very far away and bring it up to here. So this is coming from very far away. Now what is the potential energy of the 3? So as we bring this charge from very far away, it has to do work against the electric field due to Q1 and the electric field due to Q2. So there are two electric fields against which Q3 has to act, or the force that we have to apply is due to both of them. And so the delta UE for only for charge 3 is going to be done in the same way. It's going to be K Q1 Q3 over, now this distance is RB, let's call that distance R13, and this distance is R23. So this will be over R13, and the work done to overcome the electric field due to Q2 is going to be K Q2 Q3 over R23. So 1,3 and 2,3. This will be the potential energy required or gained in bringing Q3 over here. So now the potential energy of the whole system will be that due to here, and also the one that we had before. So the potential energy of the three particles is going to be K Q1 Q3 over R13 K Q1 Q2 over R12 and K 1 3, and so that's now 2 3 over R2 3. This becomes R12 to keep it general. So that will be the potential energy of this whole system when you have three particles.